Okay. Yeah. Today we have Hargroves, and let me. You can memorize this.
Oh, it's changed that part.
We have Hargroves, but who has been here every year. You all have been coming, which we welcome that. More importantly, we have two graduates. All right. Some of you would have heard me say that I had a student in my class who had photographic memory. That's them there. Adam Driggers. Always get A's and all the time. I keep scratching my head. Why? And then, of course, we have Ty, who is just as good. He didn't get the photographic memory, but he's a, both of them are successful graduates. And thank you for coming again. We have our students who are interested in hearing what you all do in terms of the job opportunities and all the types of job and also co-op opportunities. Thank you for lunch as usual. The students are hungry. Appreciate it very much. Yeah. The floor is yours.
Yeah, and we have a third alumni too. He's not here, but he's in Reed Jones.
Yes,
Savannah
Reed
office.
Jones.
Yeah, he was in Mobile for 3 years and then transferred to our Savannah office to start up a group there back in August.
Good.
So we got 3 Troy GMAX graduates. So, real quick introduction. So my name's Adam Driggers. I'm Director of Surveying and Scanning Services for Hargrove, based out of Mobile, Alabama. I'm a GMAX graduate from Troy, 2003. So it's been a while for me going through the program. I think I just dated you, Dr. Remery.
Yes, that's when I started.
So I got 19 years in surveying, dimensional control, data capture. My early part career was in the traditional survey, and the last 7, almost 8 years now has been in the 3D world. Ty?
Yeah, my name's Ty McBurnett. Been with Hargrove for just about 4 years. Well, a little over 4 years now. I graduated from here in 17, went straight to work for Hargrove, and been working with them ever since. I got my remote pilot's license, and I just got my LSIT about a year ago. So working towards getting licensed here next year. So, yeah.
All right. So a little overview of Hargrove as a whole, and then we'll jump into kind of what we do at Hargrove specifically. So we're considered a medium-sized engineering firm. We've got multidiscipline engineering from civil, structural, process, mechanical, electrical, controls and automation. We've got procurement team, project controls, the whole engineering, procurement, construction life cycle. That's Hargrove as a whole. So you see this number here at the bottom, the 2,250, that's spread out over 17 different offices. So we're primarily along the Gulf Coast. Ty and I are both out of Mobile. Reed, the other Troy graduates in Savannah. And then from a survey and scanning standpoint, besides Mobile and Savannah, we've got teams in Baton Rouge office, Beaumont, Texas, and Pasadena, Texas, which is Metro Houston, South Houston. And then we're looking kind of further down the road for growth, maybe later this year. May not happen this year or not, but Decatur, Alabama, I think is probably going to be our next geographic location where we're going to look to expand our survey services. So a little bit about the company. You know, we're medium-sized, but we do a lot of heavy industrial chemicals, pulp and paper, refining, petroleum. Those are kind of our big service industries that we work in. So it's a lot of very heavy industry type stuff. That's what we do. This is a little teaser video that will kind of give you an overview of what we do. Yes, Mike. All right, so that's kind of an overview, and we'll kind of dive in and show you and kind of go through each one of those tools that were shown in that video. So dimensional data, that's what we capture. And we're survey teams, so a lot of people think survey, they think boundary surveys, DOT, gas line on the side of the highway, looking through the toll station lens. What we do is we take those basic survey principles with basic equipment and even, more technologically advanced equipment, and we use those applications to capture data, whether that's through your traditional toll station, GPS, photogrammetry using drones, terrestrial-based LiDAR or scanners, GPR, and even sonar bathymetry. So what we do is kind of comprehensively, we call it dimensional data capture. We're surveying and scanning service provider for Hargrove as a company, but what we do is we capture data, primarily in use for 3D design for our engineering teams. So a lot of times we get in these plants, there's poor or incomplete information for the engineering teams to design off of. So it's our job to come in, capture that existing condition so that they can update their process, swap out pipe, equipment, whatever that will fit in that space to make sure that their engineering design functions as it's supposed to. So we have a huge toolbox of tools, and I'll kind of go through each different type of one that we have and how we use it. Here's kind of an overview of what all we've got. This is just in Mobile. This is just our office in Mobile, which we have 6 people in Mobile. As a group, we've got 15 total. So the 2,250 teammates, we're a very small portion of that overall size, but being our footprint stretches across the Gulf Coast, we travel, we go wherever our clients' projects take us. Tasman to Jordan, we went there 2019 to Dead Sea. We've done stuff in Shanghai, we've been to the Virgin Islands, Niagara Falls, West Coast, Phoenix, Idaho. You were in Idaho last week, so
Just about everywhere.
we go wherever the work takes us. But this is kind of an overview of the tools: drones, GPS, toll stations, scanners, GPR. We've got virtual reality that we can take this data and put into a VR environment too. So the first thing, I guess the foundation of everything we do is utilizing the survey toll station. Every tool that we have to capture data dimensionally is all based on good site control. And we run that site control with a toll station. We go out and set control and running closed loop traversers. We'll do it the traditional way, occupy and back site. We also will do what we call resectioning. Some people call it free stationing. That sometimes lends itself to be a little bit more accurate because you're taking the prism and the pole out of the equation. Therefore, you're taking error out or potential error out. And a lot of our loops, what we strive for is 1 to 100,000 closure. Extremely tight. So you're basically 100th every 1,000 feet of traverse that you run. So that's what we're shooting for, because this piece of equipment here is going to get you 0.5 data within a 1/16 of an inch, which is 5,000ths of a foot. So it's extremely tight control. Our design teams need that to do what they need to do when they're fitting pipe up or matching up pieces of steel to existing steel. It's got to be, pretty dead nuts on it. So we take that data, we run it through least squares adjustment software to ensure that the network is tight and any errors is accounted for. And we use this not for patrol. We do traditional surveys with it, topographic surveys. We do on occasion do boundary surveys. That's not kind of our niche. What we do a lot of, I'd say 95% of what we do is scanning, but every scan job has a total station that goes out to the side with it. So GPS, we've got a couple of GPS systems too. A lot of times when we utilize this tool, it's to do one of two things. It's to tie whatever data that we're capturing to a state plane coordinate system, a real world coordinate system. A lot of these plants have a coordinate system that's just based off 1,000, 1,000. So it's arbitrary. It doesn't place it in the real world at real northeast elevation. A lot of times our civil team, with whatever they're designing, municipalities may require it to be in state planes. We use this. A lot of our drone ground control points we'll set up our own base. We found it's a lot more accurate than using an RTK network. We've gotten down to about 200-300 or so on accuracy by setting up our own base. We'll shoot in ground control. We do plenty of topos with these, sometimes in wooded areas. We've got our ability to get our hands on one that works in tree canopy. So that technology has advanced in the last couple of years. It has really made our work more efficient. You don't have to worry about line of sight and cutting the line through the woods, which I can appreciate. But I'd say out of all the tools we use, that's probably the least, but with the drone, that's usually in the truck with the drone. So scanning, so this is kind of our bread and butter. This is probably what we do 90% of in industrial environments. What I have set up over there is it's a Z&F brand scanner. It's a 5016 model, so our latest one that they have released. It's the fastest, most accurate, least noisy data scanner that is on the market right now. Our standard scanning is set up and it's done in about 1:40 on black and white, about another 3 minutes or so, 3 or 4 minutes or so if you're going to do color for it to take the pictures. But the data that comes out of it is pretty crisp, and I've got some stuff that I'm going to leave with Dr. Greenrick that y'all can hopefully can get software and stuff put up and y'all will be able to take a look at it. But this is moved around an area to capture 3D points. So the motor in the middle spins vertically and the whole unit rotates horizontally and it's shooting a laser out. Anything that laser hits, it gets a point back. You're basically getting a point every millimeter. So it's a very dense network of points. We'll set scan targets and stuff around the area that we're scanning. Those targets, when I mentioned we use the survey total station to set control, those targets are shot in with the total station. And each target is basically a control point. It will ultimately have a fixed coordinate, fixed XYZ value. So all these individual scans that are done in the area, they're all stitched together using the scan targets that we place out in the field. So this generates a ton of data in a very short amount of time. On average, I say we can do 50 black and white a day, about 30 to 35 in color. Average size scan. There are, tools on the market that do cloud-to-cloud stuff and plane-to-plane registration. For what we do, that doesn't fit our workflow because we've got to be, less than an 18-inch thing. So this is our primary workhorse, and we've got one of these scanners in 5 different locations. We've got 2 in Mobile, 1 Savannah, 1 Baton Rouge, 1 Beaumont, and 1 in Pasadena. So. Take it back, the Beaumont one's a LIGO, it's B40. So target acquisition, so we put these, we should have brought one for.
Does it store locally on the?
There's a hard drive, it's a 128 gig hard drive on the.
And the battery power, how long could that run?
Those are dual batteries, so you can hot swap them. We have 4 of them, so you can go, 2 days?
Black and white scans, you can probably go 2 days with scanning it, I guess probably about day and a half. Color scans eats up a little bit more battery than black and white does.
But we've not had a problem getting cut short on a day because they send enough with them to where you can at least do a day's work and take them back to the hotel or the office or wherever and charge them overnight. But yeah, the data stored locally, we take it back to the office, we download those files to our network, and then all the processing is done on our desktops there. So I mentioned target acquisition. We place these, they're black and white checker targets, and each of them are individually numbered, so they have a unique ID all around the area. Those are surveyed in, and since those targets have a fixed coordinate on them, we're able to basically take that point cloud data and match it up and align. You pick the targets within the scan and say that's target 1, that's 2, that's 3, and lock it in place. So you do that over the course of the area. And within the software, it's got some adjustment tools and some math that it runs within the software that gets those registration accuracies down to 1 to 2 millimeters. So it's extremely accurate. Some of the software that we use, we've got a ton of software at Hargrove, probably too much. But these are just some that our team uses. I don't know if you've heard any of these from Pix4D. I'm sure y'all probably heard of that with drone data. We've got like a Cyclone, LFM, which is now Point Cloud Manager, a couple Autodesk products, Recap and Navisworks. That's what I told you about the data. Our field software is Magnet. We've got Sokia TopCon instruments that run off Magnet field, and we've got Magnet tools for the office processing side. A couple of modeling tools, ClearEdge. We can take that point cloud data and fit 3D solid objects to them, which you end up something like this, as opposed to that. This top picture is the point cloud, the actual millions of points, and then the bottom is the 3D objects that we fit to that can be built within a CAD environment. We've also got VR platforms that we can take this scan data and this model data, load it up on the cloud, put a VR headset on. I can be in our office in Mobile with a headset. We can have a guy in Savannah with a headset, and we can have a client sitting in their office and wherever they're at with a headset, and all three of us can go into the model and go walk around and point things out, from an engineering design standpoint. So none of that gets built without our involvement on the front end with the survey and scanning component. So the benefits of it, it's extremely fast, and we get a lot of data in a short amount of time. It allows our engineering disciplines to use it across all platforms. It's electronics. We put it in one location. We can have folks on civil, structural in Mobile, and then maybe a piping team in our Memphis office that are both working on the same job. They're in two different locations. Well, the data's electronic. We're not having to shuffle things around. They can both access it. So you can integrate with a 3D model. That's what our design team primarily uses for their design. It's all based in 3D. So with that data, it allows them to ensure that they're not running, their new stuff's not running into things. They're not running a pipe through a steel column or a piece of equipment or something like that. And it's all digital. So we can store it, archive it. If we need to pull it up 5 years down the road, we can. But I always say the scan's only good that day that you did it. Something maintenance team can come in the next week and run a pipe through there that you didn't catch. So, so some of these plants we stay pretty busy. Just 3D model integration, just some pictures of how we can take that model and overlay it into the scan data that we captured. You can visualize, what they're trying to do. This helps our clients a lot whenever they go and do model reviews during the throughout process of the design. They'll take our scan data, they'll take their model, they'll integrate the two, and then they'll go through their new design with the client, and they can see where their new piece of equipment is going to go and how it's going to look, and it's a very, very beneficial tool. Some of the vulnerabilities of scanning, water deflection and reflection. If you've got puddles of water on the ground, your laser is not going to penetrate them. Weather affects it. We're surveyors, we don't work in the rain. It's like most surveyors, but you see them on the windshield, we're sitting in the truck. Wind can affect it if the winds are too strong, with it being tripod mounted or if we're up on a structure, vibrations affect the ability to capture accurate data. Lack of constraints, that's meaning targets. If we're putting in an area where we didn't fully target it, where we've had good geometry spatially that's all the way around 360 degrees around the scan location, that affects it too. If we did a scan in this room and all our targets were on this wall, the scan's going to tilt that one direction. If it's only on 2 walls, it's going to tilt that direction. So, we make sure that, throughout our field processes before we go into these areas that we put targets up spatially all the way around us to ensure that it's going to come in and it's going to fit and not get pulled in one direction. All right, I'm going to turn this part over to Ty because he's one of our drone pilots.
All right, so we fly a drone, and y'all probably heard of 42 other companies that fly drones to do topo surveys, do inspections, just get quantities on big piles of rocks or logs or whatever. We're using drones not only for topographic surveys, we're using them to mesh them up with our laser scan data. Since we can only get so much from the ground or from platforms with this, we can't get the top of structures unless we went to the top of the structure. or tops of roofs where we can't put this thing. We use the drone to marry that data together. It's kind of we call it the icing on the cake. We also use it for not only to marry up with that, inspections. I mean, just yesterday I was flying through a property that was, soon to be bought, and we used it for that. There's multiple different ways we can use a drone in our business. So, yeah.
It's a lot safer to put a drone in the air. We've done several rail yard topos because rail yard, this right here is one of them. This is the main line rail right here that has 5 or 6 spurs that go off into the sugar plant in Louisiana, and is active all the time. They're moving cars in and out, and it's just not a safe environment to put people into. Well, if you don't have to get in that environment, you can fly a drone overhead and not even have to touch a rail. It's way, way safer, and you can get data 10 times faster. So we've done a lot of that. And then what Ty was talking about with the point clouds, we can take that photogrammetry data. It's all, the drones we have are all photogrammetry based. We don't have a LiDAR unit. At this point, for what we do, it doesn't justify us spending $100,000 on a LiDAR unit when we can get just as accurate data with a camera. So those series of images that are overlaid that create that 3D surface using photogrammetry software can then be exported into a point cloud format. And we can take that, it's less dense, it's less accurate. We're getting a 1/16 of an inch with this. The drone data is about plus or minus a ½ inch, but it's good enough for topo, for civil work, for dirt work. And then a lot of times we'll fly on top of a pipe rack in a plant early on in the project, so our pipe designers know, hey, there's a slot for me to run a pipe through there, or I need to miss this platform that I may not be able to see from the ground. So early phase type stuff, it's a great tool to use. And another couple of things that it also can be used for, inspections, leak detection. There are cameras and payloads out there. We haven't gotten the job yet with a client that's gonna allow us to purchase one of the leak detection cameras, but it could be coming with some of the environments we work in, trying to find hydrocarbon leaks that could be fatal to life. So, and he mentioned one we do inspections. We also did one, I wish I had put a picture in here. So in the video, y'all saw at the end with the flare stack, the fire and stuff coming out of the top. So we did one of these over in Louisiana. They shut the flare down, but they had the top 15 feet of the flare that they needed to reverse engineer. Well, it's 250 feet in the air. You can't climb a ladder up to it. You can't get into a lift to get up there to it. So the only way you could access it was to put a drone around it. You couldn't scan it from the ground because it's moving in the wind. It's moving an inch and a half each direction in the wind. So client came to us like, hey, how can we do this? I'm like, well, we can fly the drone around it. We'll take pictures. So what we ended up doing was they shut the flare down. We were able to get within 10 or 15 feet of the flare. We flew 300 series around it, took pictures at various elevations all the way around it, and we're able to take that, utilizing photogrammetry, stitch all the images together and create a 3D surface that we were ultimately able to create a 3D model from. And so we felt confident we got it within a ½ inch accuracy on this flare tip. So then they could take that to their fabrication folks to be able to reverse engineer this. They cut the top off, set the new one on, make the piping connections, and then they're ready to go. So it was a pretty cool project we were able to do. And it took, 20 minutes to fly?
Yeah, it didn't take long at all.
Yeah.
It took longer to process everything than it did to actually fly.
Yeah.
And that's the beauty of a drone. I mean, you can do a topo survey of a 100-acre site in a few hours, whereas if you were to do it by hand, it may take you 3, 4, 5, 6, 2 weeks, doesn't matter. That's the nice part about the drone. As long as your ground conditions permit, being able to fly a drone, I choose that any day over ground running anything.
Yeah. So here's some examples. This is a point cloud. This is not a picture. So we were able to take and convert that 3D surface from Pix4D and put it in the point cloud format, which is the same type of data that you get out of the scanner from Grade. That's another example of, this is all drone data right here that we captured in the plant. They had interest in, where these cable trays were running up top, because they were gonna be adding a lot of process lines, through this bike rack. So we were able to scan it from grade and then in between the levels, and then we flew the drone over the top, married all that together. This was that picture, that I showed a couple slides back, but this is, this rail yard through here, that was extremely busy. We flew that, generated topographic surface off of it. Another example, this was up in upstate New York. You went on this job, right?
Yeah.
I went and did this one. You talk.
This was in the height of the pandemic. We normally fly everywhere we can, but me and another guy we work with, we drove all the way up to upstate New York, past Rochester. It's about a 20-hour drive from Mobile. Went up there, did this survey. It's about 80 acres or so. We flew the entire thing for like a good 3D model. For most of your topo stuff, you can fly the drone over with the camera looking just straight down, and you're not really worried about the sides of the buildings or any of the pieces of equipment in there. But this whole thing, we flew it at obliques, looking down at the sides of all of the buildings, all of the pieces of equipment. And then on top of that, we flew naders all the way over the top, looking straight down, just to help tighten up our accuracy of our oblique images. And this site, they were using this to pretty much replicate if a worst case scenario flood happened with the river here. And if the flood came so many feet, it would start shutting down pieces of equipment. And there was 90% organic peroxide in this plant. And if it got above a certain temperature, it combusts. So they needed to make sure that all the refrigeration units would not go down in case that the river rose and flooded the entire plant. So we did that and we simulated a flood coming through the plant, and at what point does stuff start shutting down, or when do they need to start bringing backup power to keep these things alive. But that right there was, I want to say we did the whole site in about a day flying, maybe a day and a half of flying the drone, and that was probably close to 10,000 images on just that one property that we processed in Pix4D. And then after the fact generated that surface, gave it over to the civil team, and they made the simulation.
Yeah, and you mentioned here, there's a lot of things you want to think about, like when off survey, these type of plants, they needed to know if I got flooded and where's my critical equipment, where are my low points located on that site that's going to be affected first. Or some of these pumps and stuff that were within containment walls that were only so tall. If the water level got up to breached that wall, well, it's going to get into the pump and the pump's going to shut down. Well, that pump keeps the product cool. And the pump shuts down, the product heats up, then yeah, they're going to have explosions, they're going to have problems. So, I'm presenting you students here that are probably thinking, oh, survey is boundary and stuff like that. There's a lot more out there to it than hunting for property corners. Utilize the same principles that you're going to learn in all the classes here, but it's a little bit different application.
I never thought in a million years I'd use least squares after I left here. I use it every day. Dr. Moon appreciates that one, I'm sure.
Talk about both.
Yeah, so this is kind of one of our new business ventures. When we kind of opened up our survey department in the East Coast, they're more rely on civil type work. So we got us a boat, and we're making topos of the bottom of ponds, lakes, rivers. Most recently was the bottom of a marina. And pretty much this little boat has a sonar unit on the bottom of it that is tied into our GPS system, and he sets a path for the thing to run across the, whatever body of water at a certain pattern and to take shots on a time increment. And pretty much it's a topo underneath the water, is what he's generating with it. It really is, it's really new to us, and it's really neat technology, and there's a lot of potential there for what we're going to do with it.
Yeah, I think we bought it 3 weeks. We got 3 weeks ago.
We didn't even have it a month. But that unit right there was pretty reasonable.
7,000.
Yeah, it's actually on the cheaper end of a lot. There's some of them up there that are long as these cables with big sonar units that penetrate silt and all kinds of stuff, and you're talking $50,000-$100,000 in that, but for what we're using it for, that's really not necessary for us. So, but yeah, you can kind of see. I know it's kind of hard, but I mean, this right here this is raw right out of that after running our field finish on it, and that's pretty much a contour map. I mean, it's just like a topo, and this is the contour map out of wireframe. It's just a solid model, a surface. So it's pretty neat. I see a lot of potential with this coming up. It sure as heck beats rowing around with a paddle and a boat, taking shots out in the middle of a pond with a long GPS pole.
Yeah, that $7,000 does not include the GPS system or the data collector.
But that's just a regular. That there is a Sokia GPS, and the data collector is inside the box in there. And you just set the data collector to take a shot every however many seconds.
5 seconds or whatever, you just try the boat.
And it's just taking a shot, logging it from that sonar unit that's on the bottom of it. It's pretty neat.
All right, so dimensional control, I'll try to explain this the best I can. So we explained kind of the bulk of what we do. We have a group that's in our Pasadena office, 2 guys that we brought over a couple of years ago. And their niche is high accuracy, critical fit up measurement. And their tool that they use is Survey Total Station. It's all heavy industry, mainly oil refineries. Work is what they do. But they go kind of a step beyond what we can capture with the scanner. A lot of times where we come in with this is before the engineering designs happen. So we give the engineering team a basis, an as-built condition for here's your data to design off of. They do their new design, whether that's adding piping, steel, new equipment, and then they create their drawings and stuff. Those go to fabrication shops for the fabricators to build all of these components. Where these guys come in for dimensional control is when it gets to that point before they're ready to shut down this particular part of the plant and have their 2, 3, 4 week shutdown where they bring in construction and they rip all the old stuff out and put all the new stuff in. We got guys that will go into these fab shops, they'll check these components versus what was designed. They'll go to the field, to the actual unit where these components are supposed to fit into place, where they're supposed to bolt up on the flanges, or specific tie points on equipment. They will measure specific locations on that equipment, and take all that data, virtually fit it up in CAD. They'll take all their points, they'll do 3D, we call them 3D stick models, and they'll compare what was fabricated versus what was designed. Is it within tolerance? Is it gonna fit? We have these sections of pieces of pipe. Cumulatively, are they gonna fit from point A to point B? And then, is that section gonna fit in the unit, or is it gonna cause problems during construction and delay everything? Well, when we're in these types of plants with Chevron, Marathon, your big oil companies, time is money. And so they've got a planned 3-week shutdown. Any minute that goes beyond that time frame is money they're losing. So, because they're having to pay people, pay the construction guys to stay on site, the equipment, they may have a large crane that may end up having to stay on site, and then the unit's not back up and running, so they're not making product, so they're not able to sell anything. So where we come in is basically an insurance policy for these type of shutdowns, where we could go ahead of time, 6 months ahead of time, measure all these things and say, hey, this is gonna fit or this is not gonna fit. Let us work with you to find a solution to make sure that whenever you do go to put this piece in there, that you have a plan, so you're not having to try and force it in or have to bring it back down and re-weld it, that sort of thing. So they do, and not only pipe and stuff, at their old firm, this is a big furnace at Chevron Pascagoula refinery that they brought in. They cut a section out, and the whole bottom piece they took measurements on, and then the same thing with the top to make sure everything fit. They also have the expertise to take into account thermal expansion. So a lot of these plants have a lot of hot product running through. Some of the stuff could be 700, 800, 1,000 degrees. And so even though it's metal, even though it's anchored down, stuff moves all the time. You wouldn't believe it, stuff moves all the time. Even though you think it's a solid piece of steel or iron pipe or whatever, it's gonna move. So they have the ability to go in and, they have the expertise to go in, know where those anchor points are, determine, where they need to locate the pipe, get the material, get the thickness, and then they can calculate, all right, well, this pipe is here when it's hot. Where's it gonna be when they're not running product through it and the unit shut down, it's gonna be at ambient temperature, so it's gonna be here. So they're able to take that into account to make sure that our design team didn't design something that's gonna fit in the hot condition when it actually needs to fit in the cold condition. Some other things they do, is reverse engineering design on equipment. This right here is just a series of points that they shot with a toll station. Then they were able to hook those points up into, this is the 3D stick model. And then the final thing was we put some skins and stuff on it and made it look pretty, and we're able to do a drawing to send to our mechanical team, and they can put all the specifications on there about materials and everything to send to a fabricator so they could build this exact piece of equipment as it sits in the field. So when they take the old one out, the new one fits right into place. And they bolt everything up and they fire the unit back up and start refining oil again. And then the thing I said about the cumulative effect, this is just an example. This is only like 34-foot length of pipe. In two different sections, you got a spool A right here to this flange, and then a spool B is this one. Each of them this one has 290s, this one has 190. Well, the only error is this 90.5 degrees. It's out by half a degree. And then spool A is short by 1/8 of an inch, and spool B is long by 1/8 of an inch. Oh, well, those will cancel out. Not necessarily. So where their benefit is, they can take this as it measured, put the two pipe spool pieces together, go into AutoCAD. It was over a 3 3/4 inch bust. So by knowing that, they're able to go back to the fabricator and say, all right, y'all are gonna have a problem here because this elbow is gonna cause you to kick out. So you need to fix, something down here, like shorten this up right here to make sure it'll fit. So these are the types of things we're able to help our clients with before they get into a situation where they're spending millions of dollars a day on shutdown that extends because they have problems like this that they didn't take time on the front end to.
And some of these pieces of pipe, I've worked around some pipe that's made out of solid titanium, and one weld on this piece of pipe costs $30,000. And, a $30,000 weld in the field at that moment is probably a $100,000 weld, since they're having to do it in the field, not in their fab shop with all their stuff, So this right here is huge insurance policy for any client or any design firm.
Yeah, some pipe can't be welded.
Yeah.
Like whenever they fabricate in the shop, that's it. It's got to fit. The flanges need to match up. They can't have any bird beaks or anything like that, and the bolt hole's got to align. So it's quite a bit different, type of surveying, but it's still the same principles. They use the same tools that we do every day, toll station, when they're locating certain things, and they're traversing out throughout the particular part of the unit, mostly by resectioning. They're shooting targets or control stickers that are placed throughout the unit, and everything is to a 1/16 of an inch. I mentioned the thermal component about them being able to calculate where something's going to be hot versus cold whenever it's shut down. And then real quick, little case study here. This is an example of one of these pieces of pipe, multiple spools that were all welded together. There's eight flange connections on this thing. They're going to pick this thing up and hook it to bottom of fin fans in a crude unit. I think it was crude unit at an oil refinery. So we measured all these. That was in the laydown yard. We went to the unit, measured the 8 nozzles where they were in the unit, and to see if they were going to fit up. Well, they weren't going to fit up. They were going to have problems. So we made them aware of this before they picked this piece of equipment up with a giant crane and got everybody out of the plant and said, hey, you're going to have issues here because, you can see, some of the angles here in the middle, like they're not lining up. So they worked with the construction company, they worked with the client on a solution, and what they were able to do without having to go and like recut and re-weld this giant spool piece of pipe is, I think the solution was they worked from the outside in on each one of these, and they were able to push and pull a little bit. I think this was 12-inch pipe, pretty hefty pipe, but they were able to get to work without having to cut and without having to make a second lift. So all of this, the main culprit was right here, where you had two adjacent legs that were out 1.22 degrees. And so that affected their fit up across this hole. I mean, this thing was probably 40 foot wide. But without that, without us being there to help them determine that, they would have been fighting it, you know, and trying to. They brought it up, wouldn't fit, bring it back down. Let's cut it, make this work, bring it back up. Oh, well, this piece doesn't work now, but this one does. Bring it back down. So it's a lot of time, a lot of back and forth. So, but like I said, that is one of the other service that we offer that's kind of a little bit above and beyond the scanning and the drawing.
Do you all have any expensive mistakes?
Any what?
Any expensive mistakes?
Any expensive mistakes?
Yeah.
Yeah, we've messed up some surveys. We have one we're working through now where we're still not sure what happened with the GPS, but some of the shots didn't line up. We used two different units. They didn't line up. We didn't notice it until we got back in the office, and so we've been kind of going back and spinning our wheels. I'd say most of the mistakes that happen from a scanning standpoint is lack of targets or poor target geometry. When I said we need good spatial geometry, we aim for at least one target in every quadrant. And I mean, it's nice to be able to put two in every quadrant or one every 45 degrees or so, all the way around you. We've got a series of field work procedures and office QA procedures that hopefully catches some of these things before they become issues. So that they're just a real minor error in the beginning and we catch it before we send the data off and some engineer finds it. Hey, your scans are messed up.
DC stuffs. There's one client that won't do a shutdown without them now because they caught some stuff prior to the shutdown happening.
Yeah.
And you know, it's stuff like this. They had pipes running through places that weren't supposed to be running, and you know, it really saved them a lot on the back end. You know, that would have really caused some issues once the shutdown actually happened. So these guys that do this here, they're based out of our Pasadena office, and when these shutdowns happen, sometimes they happen for 2-3 weeks, month, 2 months. You know, and those guys are there from beginning to end, 7 days a week, 12 hours a day. And most of the time on call 24 hours a day.
Yeah. They had something going on at night, they'll have to come out there and go help them out. Some other instances of mistakes has involved units, international feet versus US feet. That's been a problem, especially with the software. For us, we understand it, but trying to explain that to some engineers, they don't get it. And the way some of the software works, the foundational unit for all Autodesk products or LFM is meters. Well, when you tell it, oh, I'm working in feet, it's going to convert to international feet. Well, in the U.S., we're America, we got our own foot. So every surveyor uses survey feet. So I know they're going to get rid of it at the end of this year. We're supposed to transition to everybody using the international feet in 2023. So that's been some headache for us too. Is make, because it doesn't matter, it's not really that big of a deal when you're on a coordinate system that's 1,000, but if you're on a state plane coordinate system that's 2 million, your difference there is 4 feet. 1,000, it's the 16th of a foot or 16th of an inch. So you're not going to see it on a local coordinate system, but you'll see it on the bigger ones whenever they try and line up a model with our scan data. And like, oh, we're 4 feet off. Well, this is why. But I mean, yeah, I mean, mistakes happen, but we have processes in place to try and catch them. So that's kind of presentation. So I know y'all got questions. I've got to.
You kind of answered my question a second ago. I was going to ask, like when they have to shut down those things for vibrations and stuff, I was going to ask if y'all go in at night or anything, but still.
Yeah, we've done stuff at night. We work in, there's been areas like food processing facilities, or I just did a proposal for one, well, I actually gotta do it tomorrow, but it's another food facility. They got fork trucks running, all different times of the day. And we asked, oh, do we need to go in here at night and do this since you don't have much traffic? But most of these places are 24/7 operation. We just gotta try and work around it. They're not gonna shut down their multi-million-dollar, operation for us to come in there and do some scans. But vibrations are usually once we get off the ground on the platforms, or if we're way up a process column, that's where we have the most trouble with it. And they're not gonna shut those down for us either. So a lot of times we get what we can, the best data that we can up there, knowing that there may be a little bit of waviness in it, and we can qualify that with our design team to say, hey, we had these issues up here, so just be aware.
Do you have any co-op opportunities?
Currently, no. So what we're looking at now is I mentioned Decatur is our next geographic region where we're looking to grow. And that may happen sometime later this year. And Savannah, we've got one client over there who we've wowed, and they are planning to bring us a lot more sites. So that would probably be a next area. If we're gonna add to the team, we probably want those two locations. The reason that we as a group don't do a whole lot of co-ops, or we've only done one co-op, and then we found out the hard way that it really didn't work for us.
I'm sorry.
But most of our client sites, unless you're a full-time employee, you can't go on site. And 90% of what we do is in the industrial plants. And so in order to go on site there, you have to be a full-time employee. So that's kind of one of the reasons that we've been kind of limited to co-op, because you get that experience. You're not gonna get that experience as a co-op just sitting in the office, throughout a whole summer. You need to be out, doing the work, capturing the data. It gives a whole different perspective to what's required. There is a current position posted for our Pasadena office in Houston. We'll be working with the DC guys.
So is the whole idea of internships, is that difficult at any office? Is that just something that every office would face?
Yeah, Hargrove as a whole, our primary industry is the heavy industrial. And so Ty will tell you, he's got a stack of safety cards that's probably 2 or 3 inches thick, having to go do safety training and drug screen, background checks.
Drug tests,
It's pretty difficult, and almost impossible, for the way that the contracts are written with our clients. It's from a safety standpoint, they want full-time employees there.
And a lot of our clients want resumes on every person that's entering their facility working on their project, because they want to know that you're qualified to do what you're doing.
Yeah.
So it's kind of hard sometimes to say, hey, we got this guy, but he's got no survey experience. He's gonna come surveying your facility, and they're like, what we gonna do about that? So.
Yeah, so what we've done in the past is we brought, Ty as an example, Reed's an example, come on full-time, and then you get thrown in. So, and kind of learn on the fly.
Did you talk about the employment package? What do you all offer?
As far as like benefits and everything?
Yeah.
Okay, yeah, a little bit about Hargrove. So we are an employee-owned company. We're 100%, we call ourselves teammates, not employees. So we're 100% teammate-owned. Benefits package is pretty good. It's health, dental, vision, 401k. They match 50% on your first 4, so up to 2. But the TSOP, or ESOP, however you want to call it, stock option plan, being teammate owned, is a nice benefit too, because you have that extra or kind of separate account for retirement later, and that all grows based on how well the company does. So everybody's got skin in the game. They're all pulling the same direction across the company to make the company successful, and that ultimately affects that account's bottom line. So as the company does well, everybody's TSOP account does well. So what
I'm virtually a free hotel stay. I stayed in enough hotels, I don't have to go anywhere and pay for a hotel.
Yeah, 2021 was a pretty busy year on the road for
2020 and 2021,
the guys.
over 100 nights on the road, so.
Yeah, we travel more during COVID than we ever have. But yeah, we do, on the road, it's, company expenses are all paid, put you up in a hotel. It's not per diem, but you expense everything. You're allotted a certain amount of dollars per day to spend on food. And everything gets expensed, but like I said, he's got all the hotel chain.
I haven't had to pay for a hotel in 3 years.
So you get to keep all the frequent flyer miles or the frequent stay nights and stuff, so that's kind of the benefit.
What does like a work week look like then? If, since y'all travel so much, you just go out on the weekends, y'all stay out?
So average size job, I said, was about 3 to 5 days. If we get into bigger projects that go beyond like a 6 day or so, 6 or 7 days, then we'll look to add a third person to it to shorten that time frame up. Most every project we have is schedule driven, and we get a PO for a project, we're the first ones in the plant, and our PMs are like, go, like y'all need to get this data turned around because nobody can do anything until you get the data in. So typical week, if we're doing out of town work, some plants have safety training on Monday mornings, you might have to travel on Sunday to get there. Some of them are drivable. Usually if they're within 15, 16 hours, we drive just because of the equipment logistics, because we've got so much we got to haul around, flying with it and checking bags. We're in small market cities with airports, except for our Houston guys, but we're gonna have to connect somewhere, so we can't get a direct flight from Mobile or Savannah or Baton Rouge. So usually we drive.
I flew to Idaho last week.
Yeah, he went to Idaho.
For the first part of the week.
But I would say there is no typical week. Everything's kind of changed, but mostly on the weekend, most everybody's home on the weekends. It's occasionally you may have a Saturday or Sunday travel day if a job runs long because of weather or whatever. It'll be a weekend. Yeah, I figured, yeah. If y'all need to go, it's no problem.
Thank you.
Yeah,
Y'all coming?
thanks for coming. So as a company, we work on a 4-10 schedule, Monday through Friday, or Monday through Thursday, 4-10s. But with us, affected by weather and client demands with projects, it's rare that everybody gets, their 3-day weekend. It's just kind of how the workflow goes. So.
But some of our clients don't like to work on Fridays, so we don't work on Fridays.
Yeah, some of them won't let us come in there on Fridays, so we don't really have a choice.
Do you guys have some kind of, you have a structured plan for somebody that would be new coming on, like road to licensure? Do you guys have something in place for that?
Not anything written down or structured. A lot of what we do, like I said, is in the industrial environment. So we do boundary surveys. I think Ty and Reed's probably done every single boundary survey since they've gotten to Hargrove. We're not your traditional firm that does strictly boundary, that's going to get you the experience that you're going to need for the application to the board. Now, are you going to get experience in using the tools and applying them in a different manner? Yes. But it may not necessarily be boundary surveys or deed research or final plat drafting, that kind of stuff. That's probably 5% of what we do, and then the 90 to 95 is this type of stuff. So
We do a lot of topo surveys.
we do a lot of topo, yeah.
But most of our work, we work out of state. So we work under engineering license most of the time. I mean, Adam's registered in Alabama, Florida, Mississippi, Georgia, Louisiana, and now we've got North Carolina. But I mean, heck, I think that Mississippi one we did a couple weeks ago would have been the first one you'd stamp in Mississippi for us. I mean.
Yeah, so we do a lot of topos, but a lot of times we're able to work across the country under our engineering CAs because what we're doing is considered engineering design support surveys. So most states allow that. There's no boundary legal title survey component to it.
We call them maps instead of surveys.
Yeah.
So working with y'all is different, like facing the board to get your licensure because of the experience you get with the company.
Right, but Ty he has not had a problem with his application, and neither did Reed. So we were able to get them enough to be able to satisfy that requirement.
Right.
So,
I take up side jobs on the weekend, you know. We've done a lot of lot block surveys for people that work for Hargrove
Right.
on the weekends, you know.
I thought that it was like, as long as you have time under a PLS, that your experience counts no matter what
That's
you're
pretty much
doing.
it.
it depends on the state.
I mean, they're
So-
hard up for surveyors right now everywhere.
So I'm in Mobile, I've got PLS, we got another Alabama PLS in Mobile, and Reed just got his North Carolina one and he's in Savannah. So,
even though you know you'd be there in like the upstate New York where you just flew the drone and everything, y'all didn't do like, I'm guessing you didn't do the boundary, right?
no,
So that wouldn't count towards boundary time whenever you're facing the board.
correct,
Gotcha. Okay.
Yeah. but we do boundary surveys, just not.
Right.
We just don't do a ton of them, but the ones that we do are pretty interesting.
Yeah, we did the battleship.
This
part.
battleship hard,
We did that, we did that.
Mobile, that was pretty neat.
Would you have any problem when you go and get your license?
I don't think so. I got enough boundary experience when I worked for Forest Service.
Sorry, I was outside.
When I did my internships for 2 summers at the Forest Service, I got a ton of boundary experience then. So, and I was under a PLS then, so what little bit I've done with Hargrove, I've also done a lot outside of Hargrove.
Reed got his license already, right?
Mm-hmm.
Yeah.
And he was working with you all, so he didn't have a problem.
North Carolina only requires you 2 years experience, or as soon as you pass the PS, no matter what your experience is, you can take your state test. So he
Passes
passes,
you get your license no matter your experience time, even though it's to your
You
state.
got that PS?
two-year state and PS, they don't require 4 years, so.
But
But-
take that LSIT test for me.
But
Just do it.
you gotta take hydro in North Carolina, that's part of the exam.
Tell them that.
Yeah, he won't let us
You're not
say
a driver? Take your LSIT before you graduate.
There's no whining about the capstone class.
No,
I tell you what, that's the hardest class, or hardest test I've ever taken.
And from the book.
You can have remembered about capstone class. I was in here the day before graduation taking that test. So,
You said that the capstone test was the hardest test you ever taken, or your FS was the hardest?
FS. I'm telling you, like, you walk out of that building, your brain feels like mush, man. I didn't even know my name after I did it.
Adam, did you pass the first time round?
Yes.
I passed second time. So. don't be
Yeah,
mad.
And Adam didn't do the we didn't have capstone.
I waited till I graduated in '03, I waited 2 years till '05 to take the FS.
And at that time,
And it
they
was-
encouraged him to take it while he was a
Yeah,
senior. He
I
didn't.
wish I would have done it before I left Troy. Now, a couple of states, Louisiana got me, but their lane laws are based on French.
Yes.
So whenever you take a state-specific exam, this is just laws pertaining to surveying in that specific state, right?
Mostly.
Yeah.
It's mostly that, board rules, history, like
Cool.
state, survey history.
Is North Carolina the only state that, does the whole pass your PS, and you can become licensed?
Or does Tennessee do that? 'Cause I know
Tennessee,
Like
Kentucky,
Tennessee's
Yeah.
2 years.
and does it too, so.
don't know for sure.
Kentucky, maybe?
Kentucky is 2 years.
Yeah, I'm not 100% sure.
But see, like, we can't do any work in Arkansas because measuring the ground in any sort is considered surveying in their state. So even if we're doing engineering design in Arkansas, we can't.
So you can't do it until you have a seat.
You have to have a
And
Arkansas license.
You have to have a stamp from.
yeah,
Arkansas.
same way with North Carolina, they changed their rule about 2 years ago to where you can't do any measurement that you're specifying an accuracy for, whether you capture it with a drone, a scanner, toll station, GPS, whatever. Anything that you're using to say that it's this accurate has to be done under PLS.
Under FS.
Yes.
Good.
Yeah. So
That's good.
that kind of locked us out of North Carolina, but now we're in, now we're trying to figure out how we get CA because they have a corporation rule too, so.
Just for my information, how many positions you have available for graduates?
Currently, I've got one that's in Houston, it's in the Houston area. It's listed as a survey tech position, but, it's entry level. And then if we grow, what we're planning on doing, North Alabama and Decatur, because we've got a Memphis office, a Decatur office, and a Birmingham office, and Decatur kind of sits right between the two. There's a lot of industry on Tennessee River, there's a lot of industry in Memphis that that team could handle, so.
Okay.
And then up into Kentucky, we got clients, we're growing into Illinois and Ohio and Iowa, Missouri, so.
I have a question. So with, the surveyors going in and y'all do like the measurements and everything, you never see the CAD, you just like pass off the data to a different, like your engineering design group or something like that, and you never see the CAD part of it?
Not the way we're operating now. We've got one group, we've got one team of 2 in Mobile that we're kind of building Mobile up to kind of operate more of a traditional survey firm where you got guys that go and do the field work and they hand it off to somebody in the office, like Ty. We've grown so much over the last 6 months that I need people like him and Reed and another guy we've got, Marty, to be able to be like survey PM. So they'll be able to take the data, they can manage the guys to go do the field work for them, or either go in the field with them and help them, but can also do some of the processing. So just about all out of the 15 we got on the team, just about everybody can currently go in the field, do what's needed in the field, bring it in the office and process data. So it's kind of
We draft all our own maps and everything, topos,
yeah,
that's.
we don't have a drafting department or anything like that. Like most everybody on the team can take their data that they capture in the field and process it and turn it into the product.
So do you still go out and field much?
Me? No.
He does go in the field, he sits in the truck when we go.
Yeah, on the farm.
I just didn't know if you still.
No, last time I went in the field was with Ty over a year ago. That was the last time I've been. So so when we started, it was just a Mobile. I don't know if you got 1 o'clock class in here?
No.
Okay. We started out real small. It was just me and 3 other people. We grew to Baton Rouge. We grew to Beaumont. We added the guys in Houston, and then Reed moved over to Savannah, and we picked up another person there. So as we've done that, we kind of got, our footprint got bigger. And so what we did a year and a half ago is upper management said, hey, it makes sense for y'all to be your own profit center. Let's break your survey group out, and Adam, you're going to be in charge of profit and loss. And you're going to keep these guys busy and these guys busy and those guys busy, and we can avoid